Hello everyone and welcome to the 2015 Aime I, where we'll tackle the first 3 questions. This is just part 1, so be sure to come back, like and subscribe for parts something through something. I don't know, probably the last question is going to take a while. Alright, so problem 1. We have two expressions, A equals a lot of multiplication and addition, and B equals a lot of multiplication and addition. Yep, there we go. And we want to find the positive difference between these two integers. Now, when you look at them, you'll see that B has like 38 times 39, 36 times 37, while expression A starts with 37 times 38, and it'll have 35 times 36. So we can sort of intuitively see here that B is going to be bigger than A. So we start by just writing down B minus A, and then we try and group together some like terms. We have 39 times 38 minus 39, we have 37 times 36 minus 38 times 37, and this sort of pattern continues onwards until 3 times 2 minus 4 times 3, and 1 minus 2 times 1. So then we try to factor some of these numbers, and we get 39 you can take out, and you get a 38 minus 1, plus 37 you can take out, you get a 36 minus 38. And this pattern continues here until here, where you take out a 3, you get a 2 minus 4, and then you finally get a minus 1 tacked on at the end. And so you'll notice that each of these is negative 2. 36 minus 38 is negative 2. 34 minus 36 is negative 2. 2 minus 4 is negative 2. And so we can just have minus 2 times the sum of all of these numbers, which is 37 plus 35 plus so on until plus 3, sorry there's no plus there, and then minus 1 at the end. And now we use this very nice formula that if you don't know it, well, you're going to know it now. Basically the sum of the first n odd numbers is n squared. So 1 plus 3, which is the first two odd numbers, is 2 squared, which is 4. 1 plus 3 plus 5 plus 7 plus 9, the sum of the first 5 odd numbers is 25. That's 5 squared. And so here we have the sum of the first 19 odd numbers, except we don't have 1. So we take 19 squared and we subtract off 1 because we don't have it inside of here. And so now all it comes down to is multiplying stuff out and making sure you don't mess up. So 39 times 37 minus 2 times 361 minus 1 is 360. And then you get 1443 minus 720 minus 1, and your final answer is 722. And now for problem 2. A good old economic cooperation conference one. Usually, if it mentions an ECC, it's something about people sitting around round tables. I don't know why, but it just is. And so we have 2 officials from Mexico, 3 from Canada, 4 from the US. In the opening session, 3 of them fall asleep because it's too boring. Of course it is. And then the 3 sleepers are determined randomly. And so we want to find the probability that 2 of them are from the same country. Now this is an example of some admittedly kind of annoying casework. So we start with assuming the 2 sleepers were from Mexico, which has 7 possibilities because we need to choose both of the Mexican delegates to be sleeping. Then one of the other 7 delegates can be chosen to be sleeping. Now if we assume 2 are from Canada, we have to choose 2 out of the 3 Canadians to be sleeping, which is 3 choose 2 or 3 possibilities, and we need to choose one of the other 6 delegates to be sleeping, so our total is 3 choose 2 times 6, which is 18. Now for 2 from the United States, same story. We need to choose 2 from the 4 US delegates, which is 4 choose 2 equal to 6, and then we need to choose 5 from the other countries, which obviously has 5 options, so our total is 6 times 5 equals 30. So this means that we have 55 ways that work. In total, we could have chosen any 3 of the 9, which is a total of 9 choose 3 or 84 possibilities. Hence our answer is 55 over 84, which goes to 55 plus 84 since it's an Aime and they always ask for, m plus n stuff, which is 139. Okay, so far so good. But then problem 3. Now you know a problem is going to be annoying if it's number theory and the problem statement is short. And the shorter the problem statement, the more difficult it is, usually. So there's a prime number p such that 16p plus 1 is the cube of a positive integer. We want to find p. So a little refresher for everyone on how mods work. So basically, if we have a number here, a, 21, so 21 cubed is congruent to 13 mod 16. This means if we divide 21 cubed by 16, our remainder is going to be 13. And we can evaluate this in very nice ways. For example, 21, when you divide 21 by 16, the remainder is 5, because, 16 and then you add 5 to get 21. So that means this 21 cubed is congruent to, that's what these three lines mean, 5 cubed mod 16. And then 5 cubed we can just expand to be 125, which is congruent to 13 mod 16 because 112 is divisible by 16. So 112 plus 13 gives us that 125. Now you might see where this is going. We have this 16p plus 1. So basically, we write our condition as some number cubed has to be congruent to 1 mod 16. And so the nice thing about this a, which you might have noticed from the previous slide, is that if it's bigger than 16, it just reduces to something less than 16. So we don't even need to check any numbers, that are particularly large to find what a is. We just need to check between 0 and 15, although there is a caveat, which I'll explain later. And we know that if a is even, then a cubed has to be even. But if a cubed is congruent to 1 mod 16, this means that a has to be odd because a cubed also has to be odd. Now the only a which works between 0 and 15 is actually just 1. You can check all the other odds if you want, but none of them are going to work. I'd recommend checking them if you're on an Aime I. And so we get that, 1 cubed is congruent to 1 mod 16, hence a is congruent to 1 mod 16. But if a equals 1, it doesn't work because we get p equals 0. So what's the next a that is 1 more than a multiple of 16? Well, 16 plus 1, or 17. And indeed, we guess a equals 17, because honestly, anything bigger would give too big of an answer for an Aime I, so that's actually how you know this is right. But if you want to show that it's correct, you do the good old 17 cubed minus 1, which is 4912, and then you divide it by 16 to find p, since remember that's what the question was asking for, which is 307. So we now technically have to verify that 307 is prime, and indeed it is. But a quicker way of doing this is noting that the next smallest answer that is congruent to 1 mod 16 is actually 33. And 33 cubed is like bigger than 30 cubed, which is bigger than 27,000. So 27,000 over 16 is bigger than 1,000, and thus it can't be an answer for an Aime I. So we're left with only 307. You don't actually really have to check that it's prime. And so with that, that's the first 3 questions of the 2005 Aime I. Thank you for watching, and remember to like and subscribe for more videos like this.